Sponsored by Sabrent.
Now in this video, we'll take a look at how to go about upgrading your system to better improve the performance when using the Flux models. The Flux models are larger than almost every other consumer model that we can use on consumer hardware. And they present a unique challenge for that reason. They can produce very high quality images and a huge diversity of images. However, to do that, they do need to have a huge amount of data. What we're going to do is to take a look at how you can improve your existing hardware to get better performance. We'll start off with laptops and then we'll move to desktops. Now, we want our data to be stored on the fastest possible storage. On your laptop, you might run out of fast storage, and this external device, which is the Rocket Nano Extreme, allows you to connect via Thunderbolt at very, very high speeds. These are 2700 megabytes per second, insane NVMe quality speeds, up to 1 terabyte extra storage, and it connects to your laptop. It's plug and play. If you haven't got Thunderbolt 3, it will run at a slower speed, but still very fast. So that's much faster than SSD, and this can allow you to store your data on the device, and you can move it from one device to another. You can move it from a laptop to a desktop. You can move it from a laptop to a laptop. It could contain all your ComfyUI files in one place, and you can run ComfyUI off the external storage. So this is a great way of extending your storage, but retaining the speed that you need to work with these very large files. Now, it will work with Thunderbolt 3 and Thunderbolt 4 and Thunderbolt 5, of course. If you haven't got Thunderbolt, there are other versions that cost somewhat less and they'll run about half the speed or so. Now, you can use these as virtual memory as well, if you know how to do that. This is not going to be a guide in how to use Windows, but having virtual memory can also improve the performance of your system as long as the virtual memory is extremely fast. An alternative method is to use an enclosure. This allows you to use whatever NVMe drive that you've got as your storage device. So if you've got an NVMe lying around and you want to use that to extend your external storage, this device can do that. The eGPU, or external GPU, is a form factor that allows you to connect a really powerful GPU with its own power supply and connections to your laptop, and it uses Thunderbolt 3, 4, 5, and you can get desktop versions of the graphics cards like the RTX 3080. There's one for the 4090 as well, but that one is currently out of supply. These ones will give you very, very fast performance on your laptop. You install the drivers, the NVIDIA drivers, and you connect the power, you connect the Thunderbolt, and away you go. You've got a very powerful laptop that is running about as fast as a desktop. Obviously, this guy here can be used with your desktop as well. If you haven't got a power supply that can handle the really, really large graphics cards that are used in gaming, this thing comes with its own power supply. That makes life a lot easier. Laptop manufacturers like Lenovo allow you to increase the amount of RAM in your system, the amount of memory. And increasing the memory is one of the best ways of improving performance when running large models like the Flux models. Some laptops don't allow you to upgrade, some do. It is something which you should consider doing if you intend to use the laptop a lot. Now, moving on to desktops. When you first upload, say, the Schnell models inside of ComfyUI, what they will require is something like 40 to 50 gigabytes of data to be loaded up to memory. And the data is loaded up, obviously, from storage. Now, the faster your storage, the faster that process will happen, obviously. With very slow storage, it can literally take hours to load up that data, and it's obviously pointless. But if you have reasonably fast data, it can even take minutes in that situation. If you've got very fast data like these T700s from Crucial, these NVMe drives, they literally will take a few seconds to load all of that data up. And they can also play a role as, we've spoken about this before, they can also play a role as virtual memory. There are 4 factors that really determine performance. Data storage is the one that has the highest delta between awful performance, which is for the old hard drives, and good performance, which is for these T700s. The cost of these is also pretty reasonable, and because of their role as virtual memory, in my view, this is probably the most cost-effective way of actually improving performance on your system. As data storage, they can actually run about as fast as some types of memory, but they are a lot less expensive gigabyte for gigabyte than going with memory. Now, people who used to use stable diffusion are at a disadvantage. They would have learned a completely different way of upgrading their system, and it would just focus solely on the GPU. When you're using the Flux models, if you're completely new to this, you're actually at an advantage because we need to take a different route. These are huge files that do not fit onto a standard consumer GPU. So once your GPU memory is completely full, you're going to be taking stuff onto your system RAM, and system RAM is super important. You can upgrade to 96 gigabytes. Now we can also upgrade to 192 gigabytes on some computers, and we can also upgrade, of course, to 128. Now, you won't get a huge boost in performance when you do this. The simple reason for that is because when your system runs out of memory, it relies on virtual memory. Windows has a very active virtual memory system. Now, does the virtual memory system rely on your storage? Yes, it does, as I explained before. Now, these very fast PCIe 5 storage can run really fast, but it introduces a ton of latency. So you really want to have as much memory as possible to absorb all the data coming from your Flux models or your control nets or anything else that you're using inside of ComfyUI. Another benefit of increasing the amount of RAM is that it allows you to do more multitasking. Now, no consumer GPU can handle all of the Flux models on board its own memory, but you can find professional GPUs like the RTX 5880 Ada generation. This bad boy is extremely fast, and it also comes with 48 gigabytes of memory, much higher than the consumer memory. And this kind of situation where you may actually be able to have a very high-end workstation that allows you to do a bit of multitasking whilst running the Flux models. That 48 gigabytes will basically boost performance like nothing else. Another alternative is the RTX 6000 Ada generation. Again, a very powerful system. This will fit inside your desktop, and it will work inside most desktops. Whereas the gaming cards, the consumer cards, you do need a really powerful power supply to run those. Again, we've got 48 gigabytes of graphics memory. These are very expensive, but they're also very powerful. Performance is very good with very stable drivers. When it comes to consumer GPUs, the most powerful at the moment is the RTX 4090. This one has 24 gigabytes of memory, GDDR6X, and it's at a couple of $1,000s. It's in short supply, and there may be a new one coming out, the 5090, within the next 3 to 6 months. Now, these bad boys have got just 24 gigs of RAM, so about half the amount of RAM of the 6000. And that's something which is going to limit their performance. They do have a very sweet amount of memory bandwidth, 384-bit bus. And that makes them very powerful when you're running the Flux models. The next most powerful consumer GPU is the RTX 4080 Super. This one is coming in with just 16 gigabytes of VRAM. It has got a 256-bit bus, which is not too bad, but it does cost quite a lot less. The RTX 4080 is one of those that has a super variant. The super variants are newer. They're much more powerful than the non-super ones. So if you have got an option to go with the super or non-super, always go with the super ones. Now, this bad boy here is the RTX 4060 Ti 16 gigabyte. That 16 gigabytes makes quite a lot of difference. What we have here, unfortunately, is a 128-bit memory bus. That's not really ideal. And we do find that that can be something that runs a little bit slower when you're running the Flux models. It is still worth going for these ones, for these bad boys here, but you won't find the incredible performance upgrade that you used to find from one generation to the next. So the 4060 Ti 16 gigabyte, fantastic performance with Stable Diffusion. When you get to the Flux models, this bad boy at about $500 will give you renders that can take under 20 seconds for a 1 megabyte render. That's excellent. Not going to cry about that. But the memory bandwidth issue is something which is actually a bit of a drawback with some of these newer ones. Where they are very positive is that they tend to run very quiet and they're very energy efficient, and they'll fit inside almost any PC. They use a very small amount of power. Now, there are a number of variety of cards that fall into the 4070 category. Some of them 4070 Ti, some of them 4070. Some of them have 16 gigabytes of VRAM, some of them have got 12. And with these ones, because they have a 256-bit bus, they're actually okay because they have more memory bandwidth. They have twice the bit bus of the 4060 Ti. So even though they only have 12 gigabytes of RAM in some situations, because you're upgrading your system memory, you're upgrading your storage for virtual memory, you're not going to notice the absence of performance, even if you go for the ones that don't have 16 gigabytes of memory. So the 4070 Ti, 4070 Ti Super, if you see those at a price that you like, I would not hesitate to go for these ones. They give you better performance, and the price of some of them is actually very reasonable. So this is an example here. The 4070, it's got 12 gigabytes. It's only $534. Sometimes you'll find these between $400 and $500. So they can be very good value. And whereas with Stable Diffusion, we didn't worry about how much system memory we had. We didn't worry about how much storage we had. We would have probably avoided the 4070 because it's just got 12 gigabytes. But because we're upgrading our entire system, it's okay. The standard 4070 non-super variant with 192 gigabytes ones, this one you can get under $500. It has to be lower in price because it's not quite as powerful in terms of the memory bandwidth, but you can use this one to get very decent performance. So if you want to get this one rather than the 4060 Ti 16 gigabyte, that will be fine. I mean, it has got more, it has 192 bit bus versus the 4060 Ti 16 gigabyte, which is 128 bit bus. That does make a difference when you're using the Flux models. So that's your options in terms of graphics cards, and the graphics cards do make a difference. Now this might leave some of you a little bit shell shocked. So what I've done is prepared an explainer which gives you a basic overview of how everything works. We've got when working with memory with large AI models like the Flux models from Black Forest, sometimes data needed for these models can be too big to fit entirely in the GPU's memory. This is where system memory and virtual memory come into play. So we're moving from the graphics card memory to the system memory. GPUs, graphics processing units, are great for AI tasks because they can do many calculations quickly. However, when they have a limited amount of memory, typically ranging from a few gigabytes to tens of gigabytes, system memory as backup. When AI model is too large to fit in the GPU's memory, the computer can use its system memory, also called RAM, as a backup. System RAM is usually larger but slower to access. Virtual memory, the extra helper. If GPU memory and system memory aren't enough, the computer can use virtual memory. Virtual memory is like a trick where the computer pretends it has more memory than it actually does. If it does this by using part of the hard drive as if it were memory. Now, when we're looking at the T700s, those very fast PCIe Gen 5 storage devices, they're not hard drive. You don't want to use a hard drive ever. They are NVMe's and they are super fast, but they have that slower to access issue as well. They have higher latency. The way that we improve this process is with the memory bandwidth on the GPU and having a couple of sticks of RAM that will occupy both of the channels, the memory channels on the computer. How it works with Flux models, let's say we're working with a Flux model from Black Forest that's really big. GPU memory, the computer tries to put it on the GPU memory for fast processing. If the model is too big, some parts of it are kept in system memory, and virtual memory becomes active when both GPU and system memory is exceeded. You really don't want that, but in any case, Windows, for some reason, Microsoft Windows will access virtual memory opportunistically. Even when these are not overloaded, it will access virtual memory, which is not very efficient. So, that's not ideal. The trade-off, while this approach allows you to work with very large models, there's a catch. Swapping data between GPU memory, system memory, and virtual memory takes time, latency. This can slow down AI processing. So that's the basic idea behind this, and hopefully you found that as a good introduction into what you need to do to improve your performance or how to upgrade your hardware. And hopefully this is a good starting point in sort of getting rid of some of the old ideas that we had about how to upgrade a stable diffusion computer when we were all just looking at the GPU and just the GPU alone.